All right, guys, so today this is just going to be a quick lesson over how to find the distance as well as the midpoint. So essentially what will happen is I will give you 2 points, or I may give you a line segment, kind of as you can see here, and I may ask you a question like, what is the distance between those 2 points? And so that's one of the goals for this lesson, to be able to use the distance formula to find that. In addition to that, I may ask you to find the midpoint of this line segment. So essentially, where's the middle spot? Where's the exact spot that breaks that line segment in half? So I'm going to start by showing you guys the distance formula. So please make sure that on your paper you are writing down the distance formula. So it's D equals square root of x2 minus x1, all of that squared, plus y2 minus y1, and all of that is squared. So make sure that you have that written down. Now, if you look at example 1, you see that there are 2 points. So we have 1 point here, which is at -5, 3. Then we have another point here that is at -2, -3. So those are my 2 points. And so the first thing you want to do is put these numbers into the formula. So this -5 is going to be considered our x1. This -2 is going to be considered our x2. Then this 3 is your y1. This -3 is your y2. So when you take that and when you plug it into the formula, this is what it should look like, okay? So if I ask you to show your work, which I will, I always want you to set it up. I will allow you to use Desmos or a calculator, but you must be able to set it up. So this is an expectation. So notice I have -2 minus -5 squared plus -3 minus 3 squared. Look closely at where I got those values from, okay? Then, after you take this, some of you are actually going to want to put it straight into Desmos. And you can actually take this entire part right here, and you can plug this whole thing into Desmos, and it will give you the exact answer. You could also go through the process of doing the math. So -2 minus 5 inside the parentheses and -3 minus 3 inside the parentheses. If you did, it would give you this. So then you're left with the square root of 3 squared plus -6 squared. All of that underneath the square root still. That would then give you 3 squared is 9. -6 squared is 36. Once again, everything is still underneath the square root. And if you add 9 plus 36, you're going to be left with 45. And so the square root of 45 is 6.71. So today I'm going to ask you to round to the nearest hundredth for this particular sheet of notes. So we get 6.71. So the distance between these 2 points, the blue and the red, is 6.71. For those of you who want to see how to put this into Desmos, I'll do an example of that real quick. So you hit the square root button here, and then you're going to type exactly what you see. So parentheses, -2 minus -5. Now what you could do is, we already know that minus and negative really becomes a plus. So if you want to, you can make that plus, but I'm just going to type in exactly what we see. So close my parentheses, squared, plus, and then we're going to keep going, plus -3 minus 3, close the parentheses, squared. And notice when you do that, it's automatically going to give you your answer. In this case, it gives us 6.7. But since we're rounding to the nearest hundredth, we need to get 2 numbers after our decimal, and there's an 8 behind it. So it bumps the 0 up to a 1, which is how we get 6.71. So that's an example now. I want you to try the second example by yourself to see if you can get it. All right, now for the second example, once again, we're doing the same exact thing, but this time I did not give you a graph. I actually gave you the 2 points. So in this case, we have the points -4, 1 and 3, -1. When we plug it into the distance formula, this is what we should have. So 3 minus -4, because 3 minus -4, those are your x values, squared, plus -1 minus 1. So -1 minus 1, and all of that squared. Once again, you can take this right now, put it into Desmos, get your answer, or you can take it step by step, which would give you 7 squared plus -2 squared, all under the radical, which is the square root sign. And you keep going, so you'd have square root of 49 plus 4. Add that together, you get 53. So when we take the square root of 53, we will get 7.28. Same thing, if you put all of this straight into Desmos, you'll get the same answer. All right, and then there's one more example. All right, now that you've solved this one out, let's see if you got the right answer. I'm going to show you my work and answer, see if it matches. So in this case, when you do the math, when you set it up, whether you put it in Desmos or if you do it by hand, you should have gotten 18.68. If you did not get 18.68, you do want to make sure you go back and check how you set it up. 9 times out of 10, if you get this answer wrong, it's because the setup was incorrect. So you want to make sure you're being very careful about setting it up with the distance formula correctly. Always reference the formula. You don't have to memorize it. So always check to make sure that you're using the correct formula. Now we're going to shift to the midpoint formula. So the midpoint formula allows us to see, once again, the middle spot of a line. So if we get a line segment, we're able to find the point that is in the exact spot that will break that line segment into 2 pieces. So here is your midpoint formula. So the midpoint is an actual point. So it means your final answer should be an ordered pair. So in order to do this, you're going to do x1 plus x2 and divide that by 2. So essentially take your x values, add them together, divide by 2. Take your y values, add those together, divide by 2. Okay, so that's all you're doing to find your midpoint. So for example, if you look at this one, we have 7 comma negative 5, and then we have 9 comma negative 1, and we're being asked to find the midpoint. So our x values are 7 and 9, and our y values are negative 5 and negative 1. So here is the setup. So when I ask you guys to show me your work for the midpoint, this is what I'm expecting to see, that you have set up those fractions. So 7 plus 9 divided by 2, comma, negative 5 plus negative 1 divided by 2. At this point, you can do the math. So for each individual fraction, you need to do that math. So you're going to want to do 7 plus 9, get that answer. Okay, you want to do negative 5 plus negative 1, get that answer. When we start to do the math here, you're going to see that 7 plus 9 is 16, and then we have 16 divided by 2. Then also we have negative 5 plus negative 1 is negative 6, and so negative 6 divided by 2. And once you divide everything by 2, you're left with your midpoint, which in this case is 8 comma negative 3. So that means if I go to the graph and I plot the point 8 comma negative 3 is going to be smack dab in between G as well as H. That's all you do to find the midpoint. So I'm going to give you guys one. So I want you to look at that second example and see if you guys are able to try that on your own. So go ahead and try it and see if you're able to get it right. All right, so we have the 2 points A and B. A is negative 7 comma 4. B is 3 comma negative 4. Negative 7 and 3 are your x values, so you should be adding those together and then dividing by 2. So for the x's, this is what we should have. And then for the y's, we have 4 and negative 4, so I should have 4 plus negative 4 all divided by 2. Once we do the math there, negative 7 plus 3 gives us, once again, you can do a lot of this calculation in Desmos, but negative 7 plus 3 is going to give you negative 4. And so negative 4 divided by 2 is essentially what we're going to need to figure out. And then also, 4 plus negative 4 is 0. So 0 divided by 2 is the next part for your y. Once you do your division, negative 4 divided by 2 is negative 2. And then 0 divided by 2, of course, is 0. So our midpoint is negative 2 comma 0. So once again, you're going to add the x's, divide by 2, add the y's, divide by 2, and you are done.